Hi, and welcome to the first presentation for Week 5 in IS 286. In this presentation, I'm going to introduce you to some new wide area network concepts. Up to this point, you have had a brief introduction to some very basic WAN concepts. This took place during IS 284. Throughout this week, we are going to add significantly to what you know about the WAN and various WAN technologies. So, let's get started. Let's start out by refreshing your memory a little bit and defining what a WAN actually is. According to Cisco and the authors of Accessing the WAN, CCNA Exploration Companion Guide, a WAN is a data communications network that operates beyond the geographic scope of a LAN. This definition is complete and accurate, but there is one part of this definition of a WAN that I want to highlight, and that is the part that states, beyond the geographic scope of a LAN. One of the big differences between a LAN and a WAN is geography. A LAN typically exists within one floor of a building, or at most maybe an entire building. It is possible that a LAN could span across two adjacent buildings, but this scenario is not extremely common. If a network spans across a city, a state, a country, or even the world, then by definition, that network is a wide area network. So what are the basic components that make up your typical corporate WAN? Well, you see some of them listed here on this slide. You should already be familiar with all of these components from IS 284. Basically, if we need to set up a WAN connection, we need a router with some type of serial connection. Remember, a serial connection consists of data terminal equipment, or DTE, on one end, and data communications equipment, or DCE, on the other end. The DTE device, typically a router that is owned by the organization that will use the WAN, will be connected to a CSU-DSU. The CSU-DSU is the device that converts the signal from the service provider into one suitable for the customer-owned DTE device. In the US, the CSU-DSU is on the customer side of the point of demarcation. So now you are wondering, what is the point of demarcation? Well, the point of demarcation is essentially the line that separates what is the service provider's responsibility to maintain and what is the customer's responsibility to maintain. The CSU-DSU is normally connected to an outlet that is installed by the service provider. Everything on the customer side of that outlet is the customer's responsibility, and everything on the other side of the outlet is the service provider's responsibility. That outlet is connected to the local loop, which is the connection to the service provider's closest switching office, often referred to as a central office. Ultimately, this results in the CSU-DSU being connected to a DCE switch that exists on the service provider's network. Keep in mind, there are numerous uses for WAN connections in the business realm, varying from connections between corporate office locations to a connection that allows an employee to access the company network from home. One of the first things that you must understand about WAN services is that they function primarily within layers 1 and 2 of the OSI model. At layer 2, you have the WAN protocols that define the physical addressing and encapsulation methods. Throughout IS-284 and up to this point in IS-285, we have been focused on one Layer 2 protocol, and that is Ethernet. But remember, Ethernet is a LAN protocol, so when we move over to the WAN side, Ethernet no longer plays a role. Frame relay, ATM, HDLC, and PPP are some of the more common Layer 2 WAN protocols that you will learn about this week. This slide shows you the various types of WAN connectors that you are likely to run into when dealing with WAN equipment. These connectors all conform to the various WAN physical layer standards. The cables that these connectors are a part of are what connect the DCE to the DTE. The next topic that we need to take a look at is WAN switching, which is entirely different from the LAN switching that we focused on in the first few weeks of this class. There are two types of WAN switched networks: circuit switched and packet switched. Circuit switched networks have been around for quite a while. As a matter of fact, the POTS network is circuit switched. If you're not familiar with the acronym POTS, it stands for Plain Old Telephone System. Instead of POTS, you may hear the acronym PSTN used. This acronym stands for Public Switched Telephone Network. Regardless of which acronym you use, it's the old landline phone system. Over the years, as technology has advanced, the circuit switched networks that were used for PSTN have also been used for more sophisticated communication methods like ISDN. For communication to occur across a circuit switched network, a dedicated circuit or channel must be set up. The path that is generated by the completed circuit is often shared by multiple communication sessions. Once the communication session is ended, the circuit is broken down until needed again. In contrast, packet switched networks do not require a circuit to be established. With packet switched networks, the communication is broken up into packets that are routed over a service provider's network, or possibly even over networks owned by multiple service providers. There are two types of packet switched networks: connectionless and connection-oriented. The Internet is an example of a connectionless packet switched network. In this type of system, addressing information is contained within each packet, and this addressing information is used at each step along the way in order to get the packet to its destination. A connection-oriented system is one that uses predetermined routes. Instead of carrying addressing information, each packet carries some type of identifier. Frame relay is used on this type of system or network, and it uses a unique identifier called a DLCI, or Data Link Connection Identifier. In some cases, the circuit will only exist while a data packet is traveling through it. This type of circuit is called a virtual circuit. A virtual circuit is, as the name implies, a logical circuit that exists within a shared network. When you hear shared network, think service provider network. This virtual circuit is connecting two devices that are communicating across the shared network. There are two types of virtual circuits: a permanent virtual circuit, or PVC, and a switched virtual circuit, or SVC. As the name suggests, PVCs are permanent connections. They are typically used for situations where data transfers are constant or nearly constant. PVCs are more efficient because the connections are not torn down and then reestablished when needed. But the always-on connection is more expensive. PVCs are configured by a service provider. The switched virtual circuit is a circuit that is established on demand and then terminated once the communication session is complete. With the required circuit establishment and circuit termination processes, overhead is a little higher, but since the connection is not constant like a PVC, it costs less to get this type of connection from the service provider. For WAN link connections, there are two options. You can either have a private WAN connection or a public WAN connection. Private WAN connections can either be dedicated links, where there is a permanent connection, or it can be a switched link. Dedicated links require a point-to-point connection, which is implemented as a predetermined path from the customer site through the service provider's network, and then ultimately ending at some remote destination like a branch office. We'll talk more about this type of connection on the next slide. With switched links, there are two options that we have already talked about: circuit switched and packet switched. We'll look at the various options that fall into these categories in a little bit. The other type of WAN link connection is the public WAN connection. This type of connection uses the internet. Now, there was a time when this was not a viable option because of the huge security risk that the internet was. However, advances in security over the years have made this type of WAN link a very viable option. Many of you may be familiar with the term VPN, which stands for Virtual Private Network. VPN technology basically creates a private, secure connection through the internet. Many companies use VPNs to provide employees with remote access to the company network. For a dedicated link, your only option is a leased line. This is implemented by the service provider as a point-to-point connection. Point-to-point lines are leased from the service provider, so you will often hear them referred to as leased lines. This type of connection is usually more expensive than the different types of shared connections that we will look at on the next couple of slides. With circuit switched connections, you have two options. The first is an analog or dial-up connection. Now, those of you who have experienced the frustration of a dial-up connection may be wondering, why would you ever use a 56 kbps dial-up connection? Well, there are quite a few situations where this type of connection is suitable. We would not want this type of connection in our home because it makes surfing the web an extremely painful experience. But when companies need to send small amounts of data or data that is not time critical, this type of connection can work fine. The other type of circuit switch connection is ISDN. ISDN uses the PSTN to carry digital signals. Many of you have probably had this type of internet connection in your home, specifically DSL. ISDN is significantly faster than dial-up. For packet switch connections, there are several options, and this slide lists the ones that are most commonly used. First of all, X.25 is a legacy network layer protocol that is becoming less common in the US. However, there are still many developing countries that are using this protocol. Frame relay is a much simpler protocol, and instead of operating at layer 3 like X.25, Frame Relay operates at layer 2. Frame Relay offers data rates up to 4 megabits per second and higher, and is very commonly used. Frame Relay provides permanent, shared connectivity that can be used to carry both data and voice traffic. We will be learning a lot more about Frame Relay throughout this week. ATM, or Asynchronous Transfer Mode, is another commonly used packet switch connection option. ATM offers both PVCs and SVCs and can be used to carry data, voice, and video traffic. Aside from the different WAN connections that we have discussed up to this point, companies also need access to the Internet. The options here are pretty much the same options that many of you have, such as DSL and broadband. With broadband, there are generally two main options, wired or wireless. For wired connections, you could have a business class cable connection, which is similar to what many of you have at home through your local cable provider, or you could have a fiber connection, as they are now becoming more and more common. As far as wireless is concerned, satellite service is a technology that has been used to provide internet access for quite a while now. At this point, I want to wrap up the discussion here on WAN connections. In the remaining Week 5 presentations, we will take an in-depth look at Frame Relay and how to configure a Frame Relay connection. We will also take a brief look at PPP, which is a Layer 2 protocol that is used for point-to-point connections. And this concludes the first presentation for Week 5 in IS 286. Be sure that you view all of the Week 5 presentations.